Formula for the area of a triangle is what we're going to look at now. So let's write and use the formula for area of a triangle. And we're going to kind of use what we talked about before. So today's goals are I can statements. I can use the area formula to find the area of any triangle. I can write and explain the formula for area of a triangle. And I know what the terms base and height refer to in a triangle. So make sure you get your I can statements, today's date, and get ready to start. So first thing we're going to do is we're going to talk about bases and heights. So on the screen here, I've got several triangles. These all at the top, those dashed lines, represents the heights of each one of those triangles. What do you notice about those heights on each one of those? Yeah, they've got that right angle symbol there. So just like what we talked about with our parallelograms, we have to have a right angle off of the base to find the height of the triangle. Notice here, these are some non-examples. They've got a dotted line, but they're not right angles. This last one does show a right angle, but what's the problem? Yeah, do you see how it doesn't quite all go up to the actual tallest part of this triangle? So it doesn't get that full distance there. So you're not getting a true idea of what the area is. Okay, so it's really about making sure that you have a right angle perpendicular to the base to get your height, and that height goes to the furthest point away, or at least goes equivalent to get it the right thing. So looking for a formula that we can use to plug in numbers to just solve out, we can think about how we found area of a parallelogram, right? How do we find the area of a parallelogram? Yeah, you should have taken the base and then found a perpendicular height and multiplied those two numbers together. And remember, we talked about how triangles relate to parallelograms. Two triangles that are the same relate to a parallelogram how? Yeah, those two triangles make one parallelogram. So if that's true, then we should be able to find something here with this. So let's get a base and a height for a couple of these and figure out what we've got. So if we take a look at this first one here on the left, we have 10 for a base, and then we have, looks like 7 for a height. Now, if this was a parallelogram, we would put all that together and multiply those together and end up with 70, right? But that's a parallelogram. This is only 1/2 of that parallelogram. So what should we do to find what the total area is? Yeah, we should divide by 2. So that gives us 35 for our area there. Okay. Let's take a look at B. Boy, this is a little hard to see which one's A and which one's B. Let me fix that real quick. Okay, so that was A. B, we have a height of 1, 2, 3, 4, 5, and 6. Oop, that's a terrible color. Let's change that color real quick. There's 6. And then we have, because remember we need a perpendicular height, and since this is a right angle, we're all set here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so we got 11 there. So that means we put 11 here. Okay, so what's that give us for an area? Yeah, if we had it doubled out as a parallelogram, it would give us 66, right? But this triangle is only half, so 33, right? Okay, so go ahead and work out the last two. There should be a link over on the side for you to try and figure out the last two so they're a little easier to see. and we'll finish out from there. So you should have been able to get these finished out. For C, I had a base of 9 going across there. And then if I look for the height on this one, I've got come straight down here and extend out my base. Now this extension for the base doesn't count in with my base. It just helps me form that right angle so I can get the height. So I've got a base of 9 and a height of 3, which gives me 27, but it should be half of that. So half of 27 is, should be oops, hang on a second, got the wrong button. 13 and 5/10. And the last one here, you had a base of 4 and a height of 11 inside there, so that makes 44. Half of 44 gets me 22. So we can really think about the base and the height as what's going on. Because remember, with a parallelogram, it was just base times height, but that was 2 of these triangles together. So can we figure out what the expression is, what we should be writing for each of these? Yeah, let's take a look here. So basically, we're taking whatever the base is times the height and dividing by 2. So something like this. So we have our base, whatever our base is, times our height. That's what we find first. And then we divide by 2. Another way you might see somebody write it as you go further in school is 1/2 base times height. Okay, remember that the dot like that between two things means it's a multiplication. So 1/2 base times height, or you could think of it as base times height divided by 2, because really when you multiply by a half, it's dividing by 2. So same thing with all of these. If you take a look at these, you can see that some people went to think about how they could make that parallelogram and then use it to solve. Well, with Elena, what she did was she looked at how she could make up to the height and make the length across to make it a full rectangle, and then just went ahead and multiplied base times height. But obviously this is going to be not the full area, it's going to be half. Jada, it's even more obvious the way she did it. She just took that same triangle and doubled it, and then did the base and height there. Lynn did something else a little unique. Lynn took a part off that had the same height, so took something that was half the height and put it off to the side. And then that works because then you're talking about this whole parallelogram here. And she already did the whole part of taking this height and putting it in half, which ends up making this entire thing half of the total area. So kind of another way to think about it. So any of these would work to help you visualize and draw out, but the formula ends up being the base times the height divided by 2. So that link from before you can still use to find the areas on each of these. Just go ahead and work out. You need to choose at least 3 of them that you want to do to find the areas. And I will come back on here in just a second. So right now you'll need to pause. You can use that link again, or you can simply work these out now that we know the formula. So for A, should have had 15 square centimeters, because 6 times 5 is 30. Half of that would get you 15. For B, we have 4 times 4, which is 16. Half of 16 would get you 8 square centimeters. C here would have been 3 for the height, and you had 7 for a base. 3 times 7 is 21. Half of 21 would get you 10 and 5/10. And then for D, you've got 8 times the 3.5. 8 times 3 is 24. 8 times 1/2, or 5/10, gets you 4. So 24 and 4 gets you 28. Half of 28 gets you 14 square centimeters. And for the final one, you've got the 5 centimeters by the 6 centimeters. So you've got 5 centimeters on the outside here for a height, 6 for a base. 6 times 5 gets you 30. Half of 30 is 15 centimeters squared. Okay. So really, you're just thinking about how the base times the height gets you a number, and then using that, what we knew from parallelograms, that the triangle is half of a parallelogram. All right. So a little vocabulary we need to make sure we get jotted down. First thing is vertex. So vertex is for each side of a triangle, there is one vertex on that side. So a vertex is where you have two edges coming together. This is terrible definition. Let me fix this super fast. So when we're talking about a vertex is where you have two or more edges coming together. So you need to get that jotted down real quick. In the case of what we were working with before, with finding the area, we needed to look at that opposite, whatever side we decided to use for a base, and we had to go to that opposite vertex of that base. So on this one, I've got line AB, and I would use point C as my opposite vertex that I would use to find my right angle here. So if I use AB as my base, then C would be my right angle to give me my height. Same thing would happen here if I went directly from here, and you guys can't see it, but off screen I have a piece of paper here to give me a right angle. And if I use AC as the line, B is what I'm going to use to go up to, because remember, I need that full height to help me figure it out. So just like we were talking about before with parallelograms, we're using basically the same theory, except that a triangle is half of a parallelogram. So we found the formula: 1/2 times of the base and the height of a triangle, or base times height, and then divide by 2. And we can write it and explain it. We talked about base being the line that we're using for whatever base that we are, and our height has to be that right angle perpendicular line off of the base to the tallest part of the opposite side. So that opposite vertex. Okay, we're all set. Make sure you've got all this down, ready to go on.